Hello everyone, and to my all dear learners, I'm Rajesh Kumar, and today I'm going to cover Python programming session 1. This session will cover the high level understanding about your program, about an algorithm, and how an algorithm and little bit of thinking can help us in an improved program. So if you see the content, I will cover what is program, then I will cover what is algorithm, then I will go to how to write an algorithm, and then I will write the first Python program for all of you, and we'll write some improved program, and we'll give some summary to end of the session for today. I'm going to use Jupyter Notebook. You can also install. So I typically use a virtual environment, to create the Python, or the notebook, or it can also spawn PyCharm or any of the editor that you wanted. You can directly go ahead and install either PyCharm, Anaconda, or if you want, you can install your virtual environment as well in Python. Let me know. I will cover one more session on how to install Python and how to work on that. But if you have got any issue or any kind of support you needed, feel free to write me in the comment so that I can help you out. So to start with, what is programming? You must have seen in any language, we have a computer have a set of instructions that only computer can understand, that we call machine language. And to interact with machine, there has to be some kind of in between mechanism. We call it as interpreter or the compiler, so that something that you are writing in your own plain English with the keywords and the command that are allowed can be understood by the computer. Therefore, if I keep all of them together, a program is a set of commands, or otherwise it is an instruction. And what we do, we give it to computer, so computer can process it and can give you some outcome or do some calculation. Either it is doing some computational calculation, or it is giving you some outcome. And the outcome can be getting a part of this string. So we may want to get a substring of the string. We may want to do some mathematical operation like addition, subtraction, exponentiation. It can be many. I just wanted to take few. We can try to do some user experience, like graphical users are doing some scientific calculations. Few examples that I quickly wanted to give you. I may want to print hello world to the user, or I want to give addition. Let's add 4 plus 2 and give 6. Outcome will be the 6. Or it can be like out of hello, how to get ELL as the substring of hello. So this is what the programming is. It is an instruction or a command, set of command we give it to computer understand that, and based on the understanding do something inside, gives us an outcome, or it does some computation. So it's like solving some complex equation. And then let's go to programming basic. What we need to do that programming. First, as I am saying, you are doing some program. We are teaching Python. It can be C, it can be C++, it can be any. So for any of this program, we need code, or we need source code. A source code is nothing but the way that this language asks you to write. You are writing a sequence of commands. Then, in order to achieve that source code, you should have a legal allowed construct and a set of keywords and the way to write those syntax. So we are allowed that in case of Python, this is the indentation, this is how we'll be following it. in case of Python, Java, we have to write this way. C, we have to write that way. So it is going to give you a syntax and will tell you do's and don'ts how to do that. Then it will have an out. And last but not the least, there will be a console where the output will get printed. Or there will be some editor where you are writing this code and the output is coming out either to some external window or within that same console. I will be showing you within the same console in a while. And therefore, these couple of things are quite important. So if you see, I have shown one. I have shown here, how to show that as a pop-up console, but I will be showing you how we can do it in our, Jupyter notebook where the output is coming within the same console as well. So let's go to our first program. Let's do that. So let's assume I have actually created that. So let me do one thing. So let's assume that the output is not there. Okay. So if I run this, I will not be getting any. And let's assume this is something I wanted to write. So what I will do, I will write print. I'm just writing the first program. Let's I will be just doing copy paste to save some time. Hello world. So this is what you see. This is called, the complete things are called source code. And what is syntax? It is like saying that if you are calling it print, it is going to print it, as well as it has to be within double quotes and within a braces. So this is a construct that you are giving to the program so that the Python program or Python interpreter or Python system, let's start with this, can understand that this is trying to print a string called hello world. And let me run that. You see, I'm able to run it. I can change it to some other name. Let's say that I am saying hello Python learners. And here I'm able to get that. So this is something called an output. This hello Python learner is output. So I said we have to have a console. So this is the console where that output is getting printed. It should have an output. So this is the output. This is the code. The complete thing is code. And what are the syntax? Print is the syntax. So print is the syntax used to print the code. All right. Similarly, I said that it can have some mathematical computation. So let's say I took A equal to 10, B equal to 12, and I'm printing to print 22. So let's see, it is 22. Let's change it. Let's change it to, let's say that I wanted 14, let's say 14 and 3, and the output I am expecting is 27. Okay. So this is my first program, or let's say this is our first program. Now going to few other details. So let's assume, let's go to the first program. What is happening? That is printing the output. How come when I am printing, or when I am saying the print hello Python learner, it is able to print that? Or what is happening when I am giving A plus B print, it is able to print 27? This is happening because there is a midway who understand the high level language. As I said in my last lecture, this is a high level language. High level language like Python, we have written a set of code in our plain English with the allowed code and syntax. And then when we are saying run, internally there is another system, or there is another construct which is within Python called interpreter, which is like a midway. So this is your code. There is another thing called machine or machine readable language, and machine who is able to read that language. And in between, we have an interpreter who is able to read, understand, and give you an output of 27. So that helps you to give the value. That is what an interpreter is. But it's not just an interpreter. There are two things that is there in different language. One is called a compiler. So what compiler does? The compiler execute or compiles the program, and that creates an executable. And this executable is run to provide the required result. So let's say that I have got hello.java. This hello.java is compiled in hello, and the output that it gives is hello.class. And then once we run hello.class, the output is hello world, because the code inside hello Java is hello world. I wanted to give one example on Java. Similarly, since I discussed already about Python, who uses an interpreter, it is little different because it does not compile. So it doesn't create an executable. It simply creates or reads and then gives out. So what interpreter did? An interpreter reads line by line, and then it converts into the machine instructions. And therefore, hello.py will directly be converted to hello world. Okay. So till here, I tried to give you some idea about what is programming. This programming I discussed in context to Python, but this is true almost with all the language. That is how it works. Now, the other construct or the other important ingredient for programmers is called algorithm. And it's very important for all of you to know. So I thought I should take few minutes and let you know what an algorithm is. So an algorithm provides steps to perform a given task in an ordered manner. Ordered manner means step 1, step 2, step 3, step 4. And in step 6, if I have to repeat step 2, I will repeat step 2, and at the end there will be a result or a termination within some condition. So we can definitely say that this is like almost like creating a recipe for a menu. If I wanted to prepare some menu or some food, there are so many chefs who have given you the recipe how to do that. We follow this and then we are done with the menu. The execution, so the actual work will be done by you, but the recipe will be provided by someone who has got the knowledge. You can take algorithm like that. Few other important characteristic of algorithm is it has got clear set of instructions. We know what exactly the inputs are, what will be the logic, and what will be the output. So the next thing, it should have a defined input and output. We should be finishing in a given number of steps. Means it should not go infinite time. There should be some finite number of steps by when we should be getting the result. And algorithm is not dependent on any of the language. Mind it, it is algorithm, no, not language. So algorithm should not depend on any of the language. Therefore, the overall algorithm construct is very important for us because it gives us a recipe that we can run or that we can recreate in any of the language, because it's not dependent on the language. So why don't we try to compute GCD? GCD is greatest common divisor. One example I thought of taking and going through all of you. So if I do that, let us write a program. how to create that or how to write that. So what we do normally in any of the mathematical, if any of the 10th pass should know, right? That those who has got those mathematical constructs should understand that a GCD is finding the greatest number that can divide both the values of GCD. So GCD actually takes two inputs. Let's call it M and N. So the value that divides both M as well as N is called GCD. For example, the GCD for 14 and 63. Let's calculate that. So the first, for 14, the common factors will be 14 can be divided by 1, 2, 7, and 14. Similarly, the common factors of 63 are, it can be divided by 1, 3, 7, 9, 21, and 23. So the total number of common factors are 1 and 7. 1 by default is for everyone. So I am not keeping that into account. And therefore, the largest factor that I can see here is 7. And since 7 is largest, the greatest common divisor for us is 7. So to sum up, how we can calculate or how we can write a program if we wanted to do the way that I have just formulated. So what we can do, if GCD of M and N we wanted to calculate, first thing we'll do is we'll list out all the factors of M, we'll list out all the factors of N, and then report the largest number which are appearing on both the things. I will do a compare, we'll check whether it is in M, what is in N, and that will be the number. So it is a finite representation of the program. And if you see, we also terminating after a given number of steps, and hence it is a algorithm. So how to create that? Let's assume FM and Fn are the list of factors for M and N. For M, we'll start from I1 to M, and what I will do, will keep dividing I with the value of FM for that time. We'll add it to FM if it is able to divide M. Similarly, I will be doing for N. I will be running a number called J1 to N. And if we say that J is able to divide N, we'll add J to Fn. This is one divisor. Then I will create a common factor. Let's call a CF as the common factor for both M. And then for each FM, and we'll add F or this factor to CF, that is the common factor, when F is appearing in Fn as well. Means that I will just making sure that both the common factors are added to CF. So I just took the example like the one earlier I said, that compare 1, 2, 7, 4 with 1, 3, 7, 9, 21, and 23, and whatever is common, keep it in here. Okay, and then return the largest value. What is be the largest value? The one which is kept at the last, which is the largest value. Don't go by the whole program. You get the intuition, and later on, once we complete basic, we can go through one more time when it will be even much clearer. Okay. We'll ignore one, because one, as I said, it will always be coming. One is dividing to all. So let's do this program now. So the way I say, create FM. So for me, FM will be a list. List is kind of a data structure or kind of a container who contains many values of of the same data type. So what we are doing, that I in range 1 to m plus 1 will divide m with I, as I said. So we'll every time we'll check whether m is divisible by 1 or not. If it is divisible, then only will be adding. Second, the similar thing will repeat for fn. Fn is the another number. So I will I will go from range I j to all the numbers. Range is kind of a data structure, or a kind of is a keyword in Python. What it does, 1 to n, default it goes to 0, but 1 to n means it will be starting from 1 and it will be going to n numbers. I will divide, do it one more time. Similarly, I will be doing CF. I will create a list, and what CF will do, CF, let's say that there is a function f will be in fn. We'll check that, and then there will be another f in fn. Will, if both are coming, it means that f, that the factor is there in fm as well as in fn, will append in f. After doing that, I am returning the rightmost value. So if I would have done cf0, I would have given the leftmost value. -1 will give me the rightmost value. The rightmost means the largest value it is going to give me. So using this, if I try GCD of 14 and 63, I'll be getting an output of 7. And similarly with the GCD of 12 and 42, I'll be getting an output of 6. Let's go to the program. Okay, so this programs as well, I'll be soon I'll be updating. I am thinking to update in GitHub. Let me know your thoughts as well. So if you see the GCD m comma n, and if you see the values, I did the same thing. I run the range. Range is nothing but from if I start from range 0 to n, then it will be taking me from 0 to n minus 1, or 1 to n, it will take me from 0 to n minus 1. So what we wanted to do here, we wanted to start from 1, and then we wanted to go till m, because m plus 1 means it will be giving 1 less as it is going to m. Similarly, I did for n, and then the value that I will have in fm and fn, I want to make sure that it is appearing both fm and fn, then only I'm adding here, and I'm returning the largest value. Let's run this program. You see, now if I run this, what I'm going to get, I'm going to get 7. So if it is instead of 64, let's make it 62. Let's see what happens. 2, because 14 and 62, only 2 is divisible. And if I make it 61, guys, any idea? If I make it 61, it is going to give me 1, because 1 is only divisible to 2. So that is how the whole program behaves. Similarly, 12 and 42, only 6 is common, and therefore you are going to give 6. If I make it 40, let's make it 36, and 12 will be the value. You see, 12. So I am not changing it. And why not changing it? I just wanted to give you people to work a little bit more. I am saving this, and let's return. This is the program that I have given, and I hope all of you must have enjoyed this, and you can write this program and start practicing. And when I will cover the whole portion, starting from how to write your program to list and others, this will be getting more and more clear. Next, why don't we improve it? So we get an intuition, we write our code, it is perfectly working, but we can make it even better. Let's use Euclid's algorithm. What Euclid says? Euclid says that if a value or a or let's say assume D is the one who divides both m and n, and it has to, because when what I am saying, a common divisor, a greatest common divisor, some divisor that is divisible to both a, m and n, and hence we are assuming, let's assume D divides both m and n, and it is just our assumption, the value of m is greater than n. So in case of like 14 and 63, m is like our 63, but n is like our 14. And if it is not there, let us swap the value and make sure that this is what we have, and hence will be the m will be n and n will be m, but because we are swapping, the nomenclature will be same. And because n now divide both m and n, assume m is equal to ad and n equal to bd, and therefore m minus n will be a minus b into d. and hence D divides M minus N as well. And because it is dividing both, we can say that the GCD of M comma N is also equal to GCD of N, the lower value, comma M minus N, the one that we are subtracted, where we assume that M is greater than N. Otherwise, we get a negative value, and hence we are assuming M greater than N. Otherwise, if you see that the values are less, we can scrap the value. And that will, I am hoping that will give us the right value. Just do that coding. Okay. So let's define GCD. We assume M greater than N. If M is less than N, let's assume what we'll do. We'll do the swap. This is nothing but to swap. So M comma N equal to N comma M means the value of M N will be assigned to M, and value of M will be assigned to N. Okay. If both are divisible, by default N. Let's assume that in earlier case we had 14 and 42. So 14 completely divides 42, hence 14. If not, we'll divide, we'll have a difference. We'll get the difference. We'll get the diff. We'll take M minus N, and we'll see that whether the diff is greater than N or not. That is something we have to see, because we'll make the change, because it is possible as well. We'll return GCD max and diff n comma mean and diff n comma diff. And why so? Because what we are doing, we are assuming at the start that GCD M comma N means M is greater than N. So the first value or the first parameter is always greater than second parameter. That is the reason if you consider the possibility that the diff may now be greater than N, what we did, that we took the max of N comma N. So in the first parameter we are getting the max value, in the second parameter we are getting the mean value, and therefore if you do, we'll get the same value. So why don't we try it out? Let's do that. So we assume M greater than N. If we see no, we'll do the swap, and if M is completely divided by N, it means the N is the only answer. If no, let's do the diff and then return the same thing. So there will be a time it so comes that N will be completely divided by N, and hence we'll get this value. Okay, let's try it out. So we do that, and you see that we are doing it in a finite number of spaces. Now it will not be an infinite number of times that it is going to work. If I run this, I'm going to get 7. If I run this, I'm going to get 6. Let's make some changes. As I said, if I do it 62, I'm going to get 2. If I make 61, I'm going to get 1. Now, if here in this case, you see, I'm getting this. If I'm making 36, means completely divided, so the 12 will be the answer. Therefore, it is a much better step. You see that we are able to do it in a very less number of steps, and we are able to get what we want. So with little thought, and I know there are a lot of things, considerations you can do, but this is something I want to show you. With little thought, we can definitely improve the quality and efficiency of our code. Okay, with that, as I said, with little effort, we can improve our program, and with the help of algorithm, we can really make it better. Each iteration, we can have better results, and a more efficient program is possible, and get ourselves how to improve that. With that, thank you so much and happy learning. Okay.